we're asking for is a trig ratio. So we do tan of theta. What did tan of theta mean again? Opposite. Remember that magic trigonometry word that we learned before, right? SOHCAHTOA. Remember it? So tan was TOA, opposite over adjacent. So for B, all we're looking for is tan theta. So in this case, what's the opposite side to theta? 24. So this is the opposite side. The adjacent side is which side? Not 26? Why is it not 26? Right. So the side opposite or right angle is always a hypotenuse. So that leaves this side adjacent to tan, to the theta, to our angle. So tan of theta is 10 over 24. Of course, we're supposed to reduce this to fraction. The lowest term is 5 over 12. So I saw that, but then I saw people going, well, you know what? I'm so stuck in the process. I'm sure you just want the angle. So I see this, or afterwards I just see theta. It's equal to tan inverse 5 over 12, and then he gave me something like 67 degrees.
I didn't see this. I just kept forgetting.
It doesn't, you know what? Regardless if you saw D or not, what is the question asking you? You need to understand that sine, cosine, and tangent are just ratios.
We're doing 5 right
Is
now.
it?
We're doing 5.
Yeah.
It's 24 over 10.
Yeah.
Yeah. Oh, sorry, it's opposite over adjacent.
Yeah.
Yeah, that was a good mark break for me too. 24 over 10. Which is 12 over 5. Okay? Fact is, we're just looking for the ratio. That's all these trigonometry functions, as we call them. They're really just ratios. If we want to find the angle, that's totally something different. We need to do the inverse of these trigonometry functions, these trigonometry ratios. And that's what question D. So I wasn't here. My other two classes, red flags immediately went off 10 minutes into the test, and they're like asking me, for number 5, do you want an exact answer? Well, what do you mean? Well, I got all these decimal places. Do you have 2 decimal places, 3 decimal places? And I knew they were down the wrong track already, right? Because you weren't giving me a fraction. Those are, to me, 2 fundamental questions of understanding trig, right? The rest of it is sort of applying it. Actually, the application part was actually done well. 8, 9, and 10. Equivalent equivalent triangles, there was some issue there. So we may need to revisit that. The hardest, the most difficult part about question number 6, we have triangles that look like this. John, mistake, focus on your please. So the diagrams will look like that. What are those lines around the corners of the triangle mean? Alex? Yeah, these are the matching angles. So sometimes it's hard to see when it's rotated. So one of the easiest thing to do is pick one triangle, draw the other one just like it. So I'm going to take this one. So let's just say my values here were 15x 20, and 16y 24. So I'm going to take this triangle and draw it like this. Okay? They're similar triangles, so they have the same shape. Now I'm going to copy my angles so that they're the same. Now they're facing the same way. What's the number between the one line and the two lines in this triangle? Y. It's Y. So this maps to that. Between 1 and 3, it's 16. Between 2 and 3 is 24. Now it's easy for me to see which sides match up to which sides and do your proportions. Now it's just 15 over Y. So I'm matching this one to this one. With 20 over 16. This one to this one is equal to X over 24. Okay. So really that was the difficulty of that one. I have spatial issues, rotating things in my head, right? Easiest thing, just redraw it, stick to your labels, and then map the sides back. And that's how we get our equivalent ratios. Okay, any questions on the word problems other than the last one? So 8, 9, and 10. 7 was done well. 8, 9, and 10 were actually done pretty well as well. The hardest one is really question number 9. This wasn't even a word problem. Question number 9. Okay? Last question. Tough one. So want to spend some time, a little bit of time on that one? Okay, so this actually was a. You guys get this last one? In completion? I don't know, I think you did, right? You took it? Pay attention. This is actually part of your homework. Actually, there were 2 questions on homework assignments based on this. They're both word problems. I abstracted it out and actually made it a little bit easier. In the actual homework, it went something like this. You had 2 people standing underneath some sort of bridge or viaduct, and they had angle elevations to a certain point on there. So it could have been, this one was 27.6, this one's 47.8. You had to figure out how high the bridge was from the ground. So really, you need to figure out this height, x, knowing that these two will be right angles. So I drew the diagram for the word problem. Now it's just basically, how do we solve this now? How do we approach this?
Yeah, we're also
Oh, sorry, yeah, the bottom was that the 2 guys were 20 meters apart or something. So that was 20. Well, first of all, how many triangles do you guys see in there? 3?
2. Oh no, 3.
2?
Wait, it's like 1 and then there's 2 inside of it. So I don't know if that counts as 3.
Sure does. It's 3 different triangles, right? Of the 3 triangles, how many actually help us? And we know actually how to deal with, to work with. Serena? 2. Why 2?
Because they're two right angles.
Yeah. Trigonometry, what we've done so far, only works with right angle triangles. So there's only 2 triangles that can really help us. We have a red one. And let's say a green one. So what we want to do is we want to break this problem down into 2 pieces then. So we just focus only on the red. What can you tell me about this triangle? Actually, we know all 3 angles. Because once we know 2 angles, we can always figure out the 3rd. What else do we know? Well, we sort of know one side length is called x. We sort of know the other side length is part of 20. So what we're going to do is we'll introduce another variable. we'll call this part of 20y. Okay? What does that leave on the other side for the green triangle? So this is y. What does that make that length then? Exactly. Yeah, I could say z, which introduces yet another variable which we don't want to do, we could prevent it. We could relate 20 and y, which is, this is really just 20 minus y. Okay? So now if we go back and look at the red triangle, what two things do we sort of know about it? We know all the angles, and we know two sides. What is the relationship there between the angles and the sides? What relationship is there? Sabrina?
Tan 27.6 equals x over y.
Yeah, so we take the tan of theta is opposite over adjacent. We realize that these two, compared to that angle, have an opposite adjacent. So tan of 27.6 is really x over y. Doesn't really help, but at least it's getting us further. Now what I want to do is, I want to isolate for one of the variables. I want to isolate for x. I could isolate for y, but I don't like how y is looking on the other side right now. But isolate for x, what do I get? How do I isolate for x? Eric?
The tan of 27.6 times y.
Yeah, multiply both sides by y. So I get really y times the tan of 27.6 is equal to x. Okay. That's also what we could do with that side. How about the green triangle? What sort of relationship or what kind of thing can we see there? Sean? Sorry?
We know the x times.
Well, we sorted, the x is still unknown.
Yes.
We know another side, which we'll call 20 minus y. Zach?
The 10 of whatever that is, 47 cents
Yeah, so we have tan of 47.8.
equals x over 20 minus y.
And once we get here, again, I want to isolate for x. So how can I isolate for x in this instance? How can I isolate for x here? Cross multiply, so basically multiply 20 minus y on both sides. Whoever's doing that, please stop. So now we have two x's. Two x's, with two variables, two equations, going way back to unit 1. How do we solve for this?
Well, what we would do is we would write 20 minus y. And then
Okay.
tan of, wait, did we find the other,
Sorry?
wait, I'm sorry. What is the other?
So here x is equal to this, and x is equal to that. So if x is equal to two things, those two things must be equal to one another.
Oh,
Right.
so it would be,
Sorry, Alex? Go ahead. So what's x equal to here? On this side, the red.
well, it would be y over tan of,
What's x equal to?
x, y times,
Tan of, that's 27.6. Okay? So x is equal to that. It's also equal to this, which is 20 minus y. Tan of 47.8.
I needed that there.
Somebody plug in tan of 27.6 for me. What's that value? The two decimal places, let's say. Tan of 27.6.
All of them.
52.2.
That doesn't sound right.
10 notes wrong.
Somebody with a calculator, help me out, please. Canada 27.6.
It is 0.
Sorry?
I know, it's 0.
0.52.
Okay, how many people do not have calculators here?
My bad, it's really far forward.
Some people are reading
I
about
don't
so
know
much.
what I'm doing wrong. I just can't read.
It's 0.52.
Thank you.
Yeah, 0.52.
Oh, I have one.
Isn't it?
Yeah,
Thank you.
0.52.
Okay.
0.52.
I don't know, man.
It's obviously one.
What's Canada 47.8?
1.1.
Sorry, 1 point.
1.
Oh.
2.
0, 2.
0.2.
Okay.
0.2.
No, 02.
1.02?
Yeah.
1.1 really.
Yeah.
So we get 0.52y. Now this is our almost like basic algebra. 20 times 1.1?
2.2.
2.2?
Wait, 20? Or is that
20
two?
times.
Oh, it's 22.
Yeah, 22.
Oh, that was two.
Thank you. Minus 1.1y. We go off, solve for y, and then we plug y back into either one of our equations, and that's how we get x. Okay?
Oh.
It's long, you should have seen what I did with the other two classes, because I killed them.
Oh,
Because I didn't even solve 10. I tried to give it a nice, elegant, poetic. Math is art.
Oh, that's what I did.
I'm the crazy one.
I didn't do
I just got 3 marks.
What I showed them afterwards was, anytime you get this situation, you get x.
Hi, Miss Lauren.
Take the time now. Everybody say hi to Miss Lauren.
I miss you, Miss Lauren.
Welcome back.
Thank you.
What I showed them at the end was, x is equal to this length times the tan of the one angle times the tan of the other angle divided by tan of the two angles added together. So when we replace 20 with y, not with y, let's say with z, anytime you're given this situation where you have two angles and the distance between them, you can always figure out that middle point of this equation. But I won't
Were
do
we
that
supposed
with
to
you
find
guys.
that somehow?
No, that wasn't part of the test, right? The test was getting to this part. But as an extension, this is what we can actually go to.